Very good morning, student. Today we can continue the topic that is friction in solid and liquids of physics. Okay. So now we have to come to that end point of the chapter, that is the Bernoulli's principle. Okay. So the last point which you have learned is the Reynolds number. Okay. Critical velocity and all these things about the fluid mechanics. Now the friction in liquids, we are coming to the last point, that is the Bernoulli's principle, and it is a very important topic for the aerodynamics also. Okay. So now, sir, what is that Bernoulli's principle first of all? But what this Bernoulli's principle is giving? What that Bernoulli's principle has stated? So Bernoulli is a physicist, and he has given particularly the relation between which relation he has given? A relation between the velocity of fluid or liquid, okay, then height, okay, height and pressure of liquid. Okay, that means particularly Bernoulli has given the relation of three quantities, that is of any fluid, that is a streamlined fluid, the relation between the pressure, velocity and height of the liquid. So that relation is nothing but the Bernoulli's principle. But sir, what is that exactly, that principle? What this principle is telling? About what that principle is? Okay, first of all we can go for Bernoulli's principle. Okay. So Bernoulli's principle states that for an ideal fluid, that ideal fluid means which is a streamline, steady flow, non-viscous, irrotational and incompressible liquid or that fluid. The kinetic energy per unit volume, potential energy per unit volume and pressure energy per unit volume, the sum of all these is always remains constant. Again I will repeat that statement. The Bernoulli's principle states that the sum of kinetic energy per unit volume, potential energy per unit volume and pressure energy per unit volume in an ideal fluid will remains constant. So that is, in one sentence we can say this is the Bernoulli's principle. Not only that, but he said the addition of or sum of velocity head, then potential head and the pressure head, this addition will also remains constant. This is his second statement. Third statement is the kinetic energy per unit mass plus potential energy per unit mass plus pressure energy per unit mass will always remains constant. This is the third statement which has given by the Bernoulli. So that is called as the Bernoulli's principle. I will write down that principle. In an ideal fluid, okay, the sum of kinetic energy per unit volume, potential energy per unit volume and pressure energy per unit volume will always remains constant. Okay, so that is the basic principle of that your Bernoulli's principle. Okay. Now question is, sir, what do you mean by ideal fluid? What do you mean by ideal fluid? So now if I want to write down ideal fluid, the fluid or liquid which he has considered as ideal, which is the streamline flow. Okay. Second is which is the steady flow. Steady means velocity of the fluid will be remains constant. Non-viscous fluid. Non-viscous means viscosity of that fluid will be 0, which is non-viscous. Fourth point, the fluid should be incompressible. What do you mean by incomprehensible? That means the density of the fluid will be remains constant throughout the its motion. So that is called as incomprehensible. And last but not the least, irrotational. Irrotational fluid. Okay. Rotational means when the body rotates about its own axis, and irrotational means when the body does not rotate about its own axis. So that therefore the liquid should not rotate about its own axis. So that is called as the irrotational fluid. Sometimes like as a cyclone, the liquid is going to flow is, that means rotation will be that it will take the rotation about its own axis. So this should not happen in case of ideal fluid. So therefore that for this type of fluid, the sum of kinetic energy per unit volume, potential energy per unit volume, pressure energy per unit volume will be always remains constant. So that is what your Bernoulli's principle is all about. Okay, again I will explain. So for which fluid he has given that principle? For the ideal fluid. Ideal fluid means which is streamline flow, which is steady flow. Now streamline means the viscosity or critical velocity of the fluid should be, or the velocity of the fluid should be less than critical velocity. Okay, Reynolds number should be less than 1000. The steady flow, the velocity of the fluid should be remains constant throughout its motion. Non-viscous, viscosity should be 0. Incomprehensible fluid, the density of fluid means density of the liquid will be remains constant throughout its motion through the pipe. And irrotational fluid means the fluid should not rotate about its own axis. So these are the characteristics of the ideal fluid, and for that ideal fluid, that sum of all this type of energy should be remains constant. So that is the Bernoulli's principle. Okay, so now so we can write down how that these three, that means kinetic energy, potential energy, pressure energy per unit volume will be remains constant. So what this kinetic energy per unit volume, what is that potential energy per unit volume? So we can think about that things, and we can write down all these, that basic principle in mathematical form. Okay, so first of all, once you got the idea about that Bernoulli's principle, and one thing you remember, this principle will give you the law of conservation of energy. Means here the energy of that fluid will be always remains conserved. Okay, just only there will be a conversion is going on, but the total energy will be remains conserved. Okay, so this is all about that Bernoulli's principle. Okay, so now in mathematically, if suppose I want to write down, so what is that kinetic energy, potential energy and pressure energy per unit volume or mass or weight? So first of all, sir, what is the kinetic energy of the fluid or liquid? Kinetic energy. So you know, kinetic energy means energy possessed by the liquid due to its motion, that is called as its kinetic energy. Okay, so now kinetic energy means energy possessed by the liquid due to its motion. Okay, we know that things. So now due to its motion, then what will be that kinetic energy? So this kinetic energy is equal to half m into v square, where m is the mass of the liquid and v is the velocity of the liquid. Okay, so that will be the kinetic energy of that liquid. And if I want to find out the factors like as kinetic energy per unit volume, then what I have, how I can find out? 1/2 mv square divided by volume. So now here in that case, 1/2 mass upon volume will be density, means 1/2 rho into v square. So this is the kinetic energy per unit volume. Second point, if I want to find out kinetic energy per unit mass, so then your equation will be 1/2 mv square divided by mass. Mass will get cancelled. So 1/2 v square. So that will be the kinetic energy per unit mass. And third factor, if I want to find out, that is kinetic energy per unit its weight. Weight means mg, 1/2 mv square upon m into g. So that mm will get cancelled, half v square upon g. So these are the three terms which we can calculate about the kinetic energy. Okay, here in that case, this kinetic energy per unit weight, this is also called as velocity head. This is, what is that term? Velocity head, or this is also called as kinetic head. Okay, kinetic head. So these are the names for that per unit weight. So that is velocity head or kinetic head. Now, similarly, if I want to find out that equation for the potential energy. So now potential energy means energy possessed by the liquid due to its position or configuration. So position means when the liquid is been kept so at a particular height, then potential energy of the liquid will be m into g into h, that we know. Now what I will do, again I will calculate the three factors. Potential energy per unit its volume. So how we can calculate that potential energy per unit volume? That is mgh upon v. Okay, volume. Okay. So now here in that case, m upon v, that is mass upon volume, is density. So rho into g into h. Okay, so that is potential energy per unit volume. Second point, if I want to find out potential energy per unit its mass, so therefore mgh upon m, and that is equal to g into h. Okay, so that will be the next point. And the third point, so we want to find out potential energy per unit weight. Okay, so now that is equal to mgh upon m into g. M will get cancelled, gg will get cancelled, and that will be only h. And that potential energy per unit weight, this is also called as potential head. That is called as potential head. Okay. So now this is kinetic energy, this is potential energy. Once you got that both the energy, then now third energy which we want to calculate, and that is called the pressure energy. But now question arises, sir, but what is the pressure energy? So if I want to find out pressure energy, then for that you should know what exactly pressure means. Energy possessed by the fluid due to its pressure exerted on the fluid, and so it will causes the, that means some displacement due to the pressure, and work has been done, and that work has been stored in the form of energy. So that is called as the pressure energy. First of all, I'll clear to you that point. What is that exactly? Pressure energy. Okay. So where should I write down? Okay. Now I'll cut this kinetic energy. Okay. So that we have learned. Now we can proceed for pressure energy. Okay. So now you see how I am calculating. Like as you know, kinetic energy, there is a formula of 1/2 mv square. Same thing, potential energy have the formula mgh. So what is the formula for pressure energy? Suppose if I will take that one cylinder, and in that cylinder, suppose here there is a piston. Okay, so we can say here what we have done, here one piston has been connected to that cylinder, and liquid has been filled inside the cylinder. So what happens, you know, so when there is a pressure is there, pressure due to height and atmospheric pressure which is exerted on the liquid. So therefore due to that pressure, the piston is going to move with certain displacement. So there will be a displacement. So now here amount of work done will be, that is the force into displacement. That displacement is supposed to be x. So that piston is moving in the forward direction. So that is x. But sir, because of that height, the pressure will be exerted. So therefore, pressure is equal, force is equal to pressure into area, because pressure is equal to force per unit area. So therefore, force is equal to pressure into area into displacement. Now, P into area into displacement means volume. So therefore, P into V, that will be amount of work done. And that work done is stored in the form of pressure energy. So therefore, pressure energy of the liquid is P into V. Okay. So now, if I want to find out, so that pressure energy per unit mass. So first factor. So that is equal to PV upon M. Okay, PV upon M. Or first of all, pressure energy per unit volume. First factor is pressure energy per unit volume. So that is V. PV will get cancelled. So that answer will be only P. So that is pressure energy per unit volume. Second point, if I want to find out pressure energy per unit mass. So the formula is PV upon M. Volume upon M. What I will do? Volume I will take down. So mass upon volume means density, means P by rho. So that is the second parameter. And third parameter, that will be your pressure energy per unit weight. Okay, so that parameter we want to calculate. So that is equal to pressure energy will be PV upon m into g. So volume will goes here P upon rho into, because mass upon volume is density, upon g. So these are the three parameters are there for pressure energy. Now you can take one by one parameter, add all these things and show the remains constant. So that will be the mathematical equation for Bernoulli's principle. So according to him, so a pressure energy per unit weight, this is also called as pressure head. That is called as pressure head. Now once you got that, then according to Bernoulli's, what he said you see here. So according to Bernoulli's principle, I will write down here. What is that principle? Okay, Bernoulli's principle. Now that principle is telling, so first, kinetic energy per unit volume. So what was the kinetic energy per unit volume? So that is equal to 1/2 rho into V square. Kinetic energy per unit volume plus potential energy per unit volume plus pressure energy per unit volume, that is equal to constant. That is the Bernoulli's principle. So now that is 1/2 kinetic energy is 1/2 rho into V square. Rho into V square. Rho is the density, V is the velocity. Pressure energy per unit volume is rho GH plus that is potential energy per unit volume, and pressure energy per unit volume that you have calculated, that is the P, is equal to constant. So this is the first statement of Bernoulli's theorem. Okay, first equation. Second equation, kinetic energy per unit mass plus potential energy per unit mass plus pressure energy per unit mass will also remains constant. Okay, so that is also another principle. So kinetic energy per unit mass. So can you tell me what was that relation? Kinetic energy per unit mass, 1/2 V square, 1/2 V square. Potential energy per unit mass, GH, plus pressure energy per unit mass, P by rho, will remains constant. This is the your second statement of Bernoulli's equation. 1/2 V square plus P by rho plus GH is always remains constant. And third equation, third statement is, I'll rub these things now, pressure energy, this equation. And the third equation is, Bernoulli's principle states, the kinetic energy per unit weight divided by potential energy divided by weight plus pressure energy divided by its weight always remains constant. So from that you have calculated kinetic energy per unit weight. Okay, so that formula will be 1/2 V square by G. 1/2 V square by G plus potential energy per unit weight, that is the height EH, plus pressure energy per unit weight P upon rho into G, that is equal to constant. So this is the expression for your kinetic energy per unit weight, potential energy per unit weight, and that is the your pressure energy per unit weight. Okay, so these are the three statements are there of Bernoulli's theorem. Okay, परत एकदा मुलांनो बर्नॉलिस थेरमचे आपले तीन स्टेटमेंट कोणकोणते आलेत मग आता P plus 1/2 rho V square plus rho into GH is equal to constant. Second equation, P by rho plus GH plus 1/2 V square is equal to constant. And third, last but not the least, 1/2 V square by G plus H plus P by rho into G will be always remains constant. So these are the three statements are there of Bernoulli's theorem. Okay, most of the time we are using this volume equation, rho gh plus p is equal to, means p plus rho gh plus 1 half rho into v square will be always remains constant. So this type of statement which we are using, or the third statement also sometimes we are using, that is the kinetic head किंवा velocity head plus potential head plus pressure head always remains constant. Okay, ह्या तिघांची ह्या हेडची बेरीज केली तर ती कशी येते मुलांनो, कॉन्स्टंट येते. ओके, सो दीज आर द युअर प्रिन्सिपल्स ऑफ दॅट युअर बर्नॉलिस थेरम. ओके, और बर्नॉलिस प्रिन्सिपल. मग मुलांना एकदा मला प्रिन्सिपल कळाल्यानंतर मग आता आपल्याला याचे ऍप्लिकेशन सर हे कुठे वापरलं जातं. ओके, तर आपण आता वन बाय वन वी कॅन सी दॅट ऍप्लिकेशन. चला आता आपण पहिल्या ऍप्लिकेशन कडे सरकूया, बर्नॉलिस प्रिन्सिपल. So that has been used in Torricelli's law. कुठे वापरलं गेलं मुलांना ते? That has been used for the Torricelli's law. Okay. मग सर आता हा काय होता सर हा Torricelli's law आणि हा कसा वापरला गेला? ओके, आता आपल्याला त्याच्याकडे आता सरकायचं मुलांना. How we can use that principle in Torricelli's law. Okay. मग मुलांना आपण आता पहिल्यांदा लिहू, explain the Torricelli's law. Okay. Torricelli's किंवा theorem. Torricelli's theorem किंवा प्रिन्सिपल. ओके, आता टॉरिसिली सुद्धा एक तुमचा मुलांनो काय होता रे, फिजिस्ट आहे हा पण. ओके, टॉरिसिलिस थेरम. ओके, किंवा त्याला टॉरिसिलिस प्रिन्सिपल सुद्धा म्हणतात. किंवा त्याला यांनी टॉरिसिलिसनी कोणतं थेरम दिलं माहिती मुलांनो? लॉ ऑफ इफ्लक्स. काय दिलं त्यांनी? लॉ ऑफ इफ्लक्स. आता काय प्रकार होता सर? व्हॉट इज द लॉ ऑफ इफ्लक्स? ओके, अँड व्हॉट ही हॅज गिवन. बट हियर दिस इज टोटली बेस्ड ऑन बर्नॉलिस प्रिन्सिपल. ओके, मग मुलांनो हे आता प्रिन्सिपल पहिल्यांदा काय सांगतं ते आपण बघूया. ओके, व्हॉट इज दॅट प्रिन्सिपल? तर तो प्रिन्सिपल बघा काय सांगतो मुलांनो. व्हॉट ही हॅज कन्सिडर्ड, फर्स्ट ऑफ ऑल बिफोर प्रोसीडिंग टू द टॉरिसिलिस प्रिन्सिपल, ही हॅज कंटेनर वन सिलेंडर. ओके, so that was the one big cylinder which he has taken into account. So now here for that cylinder, at the bottom of the cylinder he has used a one orifice. Okay, orifice. Okay, here orifice, and the water has been fulfilled into that cylinder. Okay, so this is the water has been filled into the cylinder. Okay, मुलांनो आता आपण इथे हे सिलेंडर पाण्याने भरलेलं आहे. आता टॉरिसिलिस थेरम काय सांगतो बघायला. आता मुलांनो हे इथे जे ऑरिफिस म्हणजे इथे तुमची तोटी आहे मुलांनो, आणि या तोटीमधून आता पाणी असं खाली पडणार आहे. दिस इज द वॉटर इज गोइंग टू फ्लो फ्रॉम दॅट युअर इफ्लक्स. ओके, म्हणजे फ्रॉम द ऑरिफिस. मग मुलांनो आता इफ्लक्स म्हणजे काय सर? व्हॉट इज इफ्लक्स? इफ्लक्स म्हणजे आउटफ्लो ऑफ फ्लुइड किंवा आउटफ्लो ऑफ लिक्विड. आणि कुठून येणार आहे तो? ऑरिफिस. ऑरिफिस. ऑरिफिस काय माहिती का? दॅट इज द ओपनिंग थ्रू विच द वॉटर इज गोइंग टू कम आउट. ओके, सो दॅट इज द ऑरिफिस. म्हणजे त्यालाच आपण होल शब्द प्रयोग सुद्धा करू शकतो मुलांना. मीन्स थ्रू द होल वॉटर इज गोइंग टू कम आउट. ओके, मग मुलांना आता ही जी हाईट आहे याची वॉटरची टँक मध्ये, हिला मी काय नाव देतो? समजा y1 म्हणतो मुलांना, आणि हे बॉटम पासून, आणि ही जी ऑरिफिस आहे तिची हाईट y2 आहे बॉटम पासून. आणि मुलांनो या दोघांमधलं डिफरन्स जो आहे, या दोघांमधला कोणामधला, ही पूर्ण हाईट आणि ह्या ऑरिफिसची ही जी हाईट, याला आपण y2 मायनस किंवा y1 मायनस y2 याला मी नाव देतो मुलांनो, दॅट इज द युअर y किंवा इकडचा y1 म्हणून घेऊ आपण, याला y1 म्हणा हरकत नाही ऑरिफिसला, आणि याला y2 मायनस y1 इज इक्वल टू h असं आपण इथं कन्सिडर करू. ओके, एवढी ती हाईट असेल मुलांना. ओके, आणि आता हा टॉरिसिलिस थेरम इथं काय सांगतो बघा. पहिल्यांदा टॉरिसिलिस लॉ काय म्हणतो बघा. टॉरिसिलिस थेरम स्टेट्स दॅट द व्हेलॉसिटी ऑफ इफ्लक्स which is coming out from the orifice is the same as the velocity of a body which is falls from the free surface of liquid up to the orifice. So now, sir, what is the meaning of that statement? What is the Torricelli's theorem? And that theorem I will explain to you first. And he has used the Bernoulli's principle basically. What is that theorem? According to this theorem, velocity of efflux. Efflux means outflow of fluid. Outflow of fluid coming from orifice is same as the body falls from free surface of liquid surface of liquid free surface of liquid to the orifice. म्हणजे मुलं हा ऑर्फिस आहे, हा होल आहे. म्हणजे एखादी बॉडी जर मी इथून सोडली तर इथपर्यंत ती जी वेलॉसिटी अक्वायर करेल तीच वेलॉसिटी ते जे पाणी आहे या ऑर्फिस मधून या होल मधून बाहेर पडेल ना, तर ते त्याच वेलॉसिटीने ते बाहेर पडलेलं असेल. आणि ते आपल्याला प्रूव्ह करायचं मुलांनो. V is equal to square root of 2 times g into h. So that will be the velocity. सर ही कशी असते सर? मग तुम्हाला माहिती आहे मुलांना, आता मी जर समजा तुम्हाला डायरेक्ट सांगितले एखादी बॉडी वरून इथपर्यंत पडली तर तुमच्याकडे इक्वेशन काय आहे? v square is equal to u square plus 2 times gh. इनिशियल वेलॉसिटी ऑफ द वॉटर इज 0. v square is equal to 2 times gh. म्हणून v is equal to under root of 2 times gh. म्हणजे it is same as the velocity falls from the free surface of liquid. पण मुलांनो हे झालं आपलं एक कायनेमॅटिक्स इक्वेशन वरनं. तर आता मला हे बर्नॉलिस प्रिन्सिपल वरनं हा टॉरिसेलिसचा थेरम कॅल्क्युलेट करायचा आहे, नोट करायचा आहे. v is equal to under root of 2 times gh. मग त्याच्यासाठी मी आता काय करतो मुलांनो, I am going to consider here in that case a one cylinder, okay, and that cylinder which is that means full of water having the density is supposed to be rho. म्हणजे rho is the density of water. Okay, आता बघा मुलांना, rho is the density of water. And that water has been fulfilled up to height y2. Okay, y2 is the height of water from the bottom. Height of water from the height of free surface of water. Free surface. कारण हा तुमचा surface कसा आहे? Free आहे. Free surface of water from the bottom. Okay, हा झाला y2. y1 is the height of orifice from the bottom. Okay, and h is the difference of y2 minus y1. Okay, now I have considered the 2 points, point P and point Q. Point P is considered to be a free surface and Q is that means from which the water is going to come out. So that is the orifice. Okay, these are the 2 points. At point P, free surface, A will be the area of free surface of liquid. V will be the velocity. म्हणजे किंवा याला मी आपण एक काम करू आपण. Okay, V will be the velocity of a liquid. Okay, मी काय करतो मुलांनो, एका पॉइंटला म्हणजे इथं समजा आपण याला काम करू. हा जो आहे ना, इथं वेलॉसिटी v घेऊ ह्या लिक्विडची आणि एरिया त्याचा a2 घेऊन टाकू. चला, a2 v2 will be the velocity of liquid at this point. मुलांनो, at point Q, A1 be the area. हा A1 be the area and its velocity will be v1. v1 be the velocity of a fluid at this particular point. A1 v1, A2 v2. Okay, now according to equation of continuity, काय इक्वेशन सांगत होतं आपल्याला कंटिन्युटीचं? according to equation of continuity. त्यात इक्वेशन बघा काय होतं मुलांना. A1 v1 is equal to A2 v2 means this area multiplied by velocity is equal to this area multiplied by this velocity. Okay, मग मुलांनो मला ह्या केसवरनं आता मी जर असं म्हटलं मुलांनो, ह्या केसमध्ये v2 is equal to velocity at the free surface of liquid is equal to A1 upon A2 into v1. पण मुलांनो A1 अपॉन A2 मध्ये A2 खूपच मोठा आहे, A1 खूप छोटा आहे. ऑरिफिस म्हणजे होल एकदम छोटा आहे आणि हा फ्री सरफेस खूप मोठा आहे. मग इफ A2 is very greater than A1, so can you tell me what will be the velocity V2? मुलांनो हा किती झालेली असेल? इट शुड बी नॅचरली 0. समजा हा इन्फिनिटी आहे, हा खूपच कमी आहे. एनिथिंग अपॉन इन्फिनिटी विल बी 0. 0 into anything will be 0. म्हणजे velocity of that liquid at that point will becomes 0. म्हणजे मुलांना इथे लिक्विड कसं आहे, स्टेबल आहे. It is not in motion. So that velocity at this point is 0. Okay. Now what I will do, I will use the Bernoulli's principle at this point and this point, and then I will get this equation V is equal to root 2 times G into H. Okay. आता आपण हे सर्व डेटा लिहिलेला आहे. आता Bernoulli's principle लिहायला मी सुरुवात करतो मुलांना. ओके. चला मुलांना आता आपण लिहून टाकू what is the Bernoulli's principle at this particular point. So according to Bernoulli's principle, okay, at point A किंवा at point P, at point P we can use the Bernoulli's principle. चला मुला आता इथे लिहू आपण. आता हे Bernoulli's principle मी कशाच्या फॉर्म मध्ये लिहितो माहिती आहे? प्रेशर एनर्जी पर युनिट व्हॉल्यूम म्हणजे P. ओके, प्रेशर एनर्जी पर युनिट व्हॉल्यूम इज P. Then kinetic energy per unit volume, that will be one half rho into V. इथे किती घेतला मी V2 square plus your potential energy per unit volume means mass upon volume means density rho G H, and H will be here Y2 is equal to constant. पहिले इक्वेशन या पॉइंटला. ओके. Second equation at point Q, write down the equation. Chalo, write down here. Pressure energy is again P, atmospheric pressure. इथं पण atmospheric pressure आहे, इथं सुद्धा atmospheric pressure P आहे. Plus half rho into इथली velocity होती मुलांनो V1 square plus इथली rho Gy1 is equal to constant. This is the second equation. Okay. म्हणजे मुलांनो आपण दोघं ठिकाणी ते इक्वेशन लिहून टाकले. आता पहिल्या इक्वेशन मध्ये तुम्ही V2 किती काढून ठेवलाय आपण? V2 is equal to 0, but velocity at point 2 is 0. So therefore at point P equation will becomes from equation 1 P plus 1 half rho V square will become 0. P plus rho into G into Y2 will remains constant. याला मी तिसरं इक्वेशन म्हणतो. ओके. मग मुलांनो second equation is also equal to constant. Third equation is also constant with an equating second and third. Okay, means if you can equate, that means equating equation 2 and 3. Okay, आता मला ते इक्वेशन काढून ठेवायचे. आता मी इथे लिहून ठेवतोय. मला प्रूव्ह काय करायचंय? V is equal to root 2 times Torricelli's theorem. V is equal to 2 times velocity of a liquid which is flowing through that orifice will be 2 times G. हे प्रूव्ह करायचं याच्यावरनं. आता मी काय केलं आता दुसरा आणि तिसरा इक्वेट करतो. फ्रॉम 2 and 3 from equation 2 and 3 आता लिहा मुलांनो. P plus half rho into V1 square plus rho Gy1 is equal to P plus rho into G into Y2. दोघं कॉन्स्टंट होते, इक्वेट करून टाकले. मुलांनो प्रेशर कट करतो, ॲटमॉस्फेरिक प्रेशर. आता एक काम करतो, हा इकडे असाच राहू देतो. 1 half rho V1 square is equal to rho Gy2 minus rho into G into Y1. मुलांनो इथून रो कॉमन काढतो, रो G कॉमन निघेल. Y2 minus Y1 is equal to rho V1 square. Rho density of the liquid is constant. I will cut this density. 1 half V1 square. V1 is the velocity of the, that means liquid through the orifice. म्हणजे हीच velocity मला काढायची मुलांनो. आणि ही एवढी यायला पाहिजे. V1 is equal to this. मग मुलांनो आता G into Y2 minus Y1 तुम्ही नोट केलंय. Y2 minus Y1 is H. Okay, that is the H. So therefore V1 square is equal to 2 times GH, or V1 is equal to root of 2 times G into h, where g is the acceleration due to gravity and h is the difference between the height of that your free surface of liquid from the bottom and orifice, the height of orifice from the bottom. Okay, so that is the your equation for the Torricelli's theorem. V1 is equal to 2 times G into H, and this is the same as any body which is falling freely from the free surface of liquid to the up to orifice. So that is the one and the same. Means by using the Bernoulli's principle, we are able to find out the velocity. Okay, so that is the first equation. Okay, so this equation shows the speed of efflux is same as freely falling body. It is known as Torricelli's law. Okay, हा क्लिअर झाला मुलांनो? यस. आता हा लॉ जर झाला असेल तर आता आपण पुढचा लॉ बघूया मुलांनो. पुढचा हे बघूया, पुढचा ऍप्लिकेशन्स आता त्याच्यामध्ये अजून मुलांनो या बर्नॉलीजने वेगवेगळे ऍप्लिकेशन्स घेतलेत. आता कुठे कुठे घेतलेत सर हे बर्नॉलीजचे ऍप्लिकेशन बघा मुलांनो. दिस ऍप्लिकेशन्स आर पर्टिक्युलरली इन व्हेंचुरीमीटर. कुठे घेतलं मुलांनो? दॅट इज इन व्हेंचुरीमीटर. व्हेंचुरीमीटर. ओके, सो दिस इज द फर्स्ट ऍप्लिकेशन. मग मुलांनो आता हा व्हेंचुरीमीटर म्हणजे काय होता रे? व्हेंचुरीमीटर इज अ डिव्हाइस, ओके, in which the speed or velocity of the liquid which can be flowing through that pipe can be calculated, as well as the rate of flow of fluid which is flowing through that pipe which can be calculated. So that is called as the व्हेंचुरीमीटर. So this is the second application. That also we want to learn in detail. Third applications we want to learn in pitot tube. Okay, pitot tube. Pitot tube is also same as the tube in which the rate of flow of liquid that can be calculated. Okay, but that flow of liquid should be steady. Okay, means we should move with the constant velocity. So that rate of flow of fluid can be calculated in case of pitot tube. Okay, so that is the second application. Okay, it is a device which is used to measure the rate of flow of liquid across any section of pipe. Then water pump. Okay, next application which is we have to use is the water pump. In water pump, particularly in rural areas, today also water pumps are there. They are taking the pipes. Okay, so they are using the Bernoulli's principle. In water pump is also, that means in water pump is also Bernoulli's principle has been used to reduce the air inside the pipe. Okay, so whatever to reduce the pressure of air contained in a vessel. Okay, whatever the that means air will be there inside the vessel, so that can be reduced by using the your water pump, by using the Bernoulli's principle in water pump. So that is the fourth application. The fifth applications that we want to learn, that is the Bunsen's burner. Okay, you have learned Bunsen's burner. Okay, sir, what is the Bunsen burner? Bunsen burner is nothing but the, that is also based on the Bernoulli's principle. That means here to burn the top of that means Bunsen burner. Okay, means here that means whatever the Bunsen burner, that whatever the flame which we can see at the top most of the burner, so that is because of that means your Bernoulli's principle. Okay, and last but not the least, that is the air purifier. Okay, that is the air purifier. So now sir, what is the air purifier, or that is also called as atomizer, or that is also called as atomizer. So now what is that purifier, or what is that atomizer? So purifier, air Bernoulli's principle has been used like this, means which we can be spread the scent to that your different parts. Okay, or we can also say that it is used to spraying the scent in air, which works on Bernoulli's principle. So you can say, sir, how we can spray the that means scent by using the Bernoulli's principle? You know the sprayer. So in the that means we can say marriages also the spray can be, that means scent can be sprayed. Okay, so how they are doing, you know, in the sprayer. So there will be, that means when the pressure will be exerted at the topmost position of that orifice, then what happens, you know, the force, what we can say, the pressure is more. Okay, pressure is less, but the velocity will be more, and so therefore that liquid is going to get made cut in the form of spray. So that is the atomizer or purifier. So these are the 6 applications are there of that your Bernoulli's principle. Now second applications which we want to learn is the Venturimeter. Okay, which is based on the that your uh, that means we can say that Bernoulli's principle. Okay, in manometer, that means these equations which that we have been learned. So on that we have learned the, that is your venturimeters. Okay, so we can proceed for the next point, that is the venturimeter. Okay, so sir, how we can find out that, that means how we can calculate the venturimeter, that means for particularly what is that device and how we can find out the measures of flow of velocity in incompressible fluid. Okay, so first of all we can prepare the diagram for venturimeter, and then we can write down by using the Bernoulli's principle equation and find out the velocity. Okay, so first of all, what is the venturimeter? Okay, so that we want to learn. Okay, I grab these things. Venturimeter. Okay. Venturimeter. Okay. तर मुलांनो आता मी कसं हे डिव्हाइस काढतो बघा. That actually this device will be like this. Okay. So actually this is the horizontal pipe, and just I am showing, that means flow of light for this point, and this is the manometer actually. Okay. U-tube, a U-shaped tube is there, that is the manometer. Okay. So here in that case, okay, so this is the way how we have to show that flow of fluid. Okay, so that is the manometer. Here we can fulfill the liquid. Okay, fill the liquid having the same density. Okay. So this is the height at these two particular points. Okay, so that is the how that manometer is there. Okay, this is the height flow of fluid. Okay, आणि मुलांनो म्हणजे मी काय केलं आहे, ही जी हाईट आहे ही अशी इथं तुम्हाला क्लिअर करून दाखवली, ही हाईट आहे. त्याच्यानंतर इथं दोन पॉईंट आपण घेऊया. फ्लो ऑफ फ्लुइड. ओके, हा पॉईंट पी टाकूया. ओके, पॉईंट पी आपण इथे नोट केलेले आहेत मुलांना. ओके, सो दॅट विल बी द पॉईंट. ओके, मग मुलांना आता आपण आता या पॉईंटकडे जाऊया. हा व्हेंचुरोमीटरने एक्झॅक्टली काय आहे, कसा आहे आणि हा कसा वर्कआउट होतो. ओके, तर आपण आता सुरुवात करूया मुलांना व्हेंचुरोमीटरला. ओके, व्हॉट इज दॅट व्हेंचुरोमीटर? So first of all, define it is a device to measure the flow of velocity in incompressible fluid. Okay, what is venturimeter? It is the device which is used to find out to use, or it is a device to measure the flow of velocity, which is used to measure the velocity of a कोणाची रे, the liquid ची velocity of incompressible fluid, of incompressible fluid. हे म्हणजे मुलांनो व्हेंचुरोमीटर. It is device which is used to measure the velocity of incompressible fluid, that is called as the venturimeter. आता मुलांनो या व्हेंचुरोमीटर मध्ये मग आपण आता काय काय घेणार बघा. पर्टिक्युलरली it consists of a manometer containing liquid of a density rho. ओके, आणि मुलांनो म्हणजे याच्यात आपण दोन पॉईंट कन्सिडर करून टाकू, पॉईंट पी आणि पॉईंट क्यू. ओके, किंवा पॉईंट ए अँड पॉईंट बी. ओके, असे दोन पॉईंट आपण घेऊन टाकू इथे, किंवा पी आणि क्यू हे पॉईंट घ्या. त्यांच्या याच्यामध्ये त्यांच्या हे कॅल्क्युलेशन करा. म्हणजे समजा आता मी इथं हा एक पॉईंट पी टाकला मुलांनो आणि हा एक पॉईंट आपण क्यू टाकू. मग आता ॲट पॉईंट पी, नियर द पॉईंट पी. So first of all again I will explain. So that venturimeter is a device which is used to measure the velocity of incompressible fluid. And here in that case, so this is supposed to be a horizontal pipe at one particular height. Okay, so the height of that pipe is the same for at both the points P and Q. Okay, but here as the U-shaped tube is there, we have filled that U-shaped tube with the liquid having the density rho. Okay, and at these two particular point P and point Q. Okay, so suppose this is the point P and this is the point Q. So at point P we can consider A is the area, okay, or A1 is the area of that your liquid. Then now V1 is the velocity of a liquid at point P, okay, A1 V1 and rho is the density, rho is the density and density कशी असेल मुलांनो, कॉन्स्टंट असेल. Q पॉइंटला नोट करा इकडे, त्याचा एरिया A2 टाका, एरिया ऑफ फ्लुइड or liquid which is going through that pipe is A2. Then V2 be its velocity at that particular point, V2 be its velocity and rho is its density. ओके, आता ह्या Q पॉइंटला म्हणजे आपली हे कंडिशन अशा आल्या, म्हणजे पॉइंट P एक पॉइंट Q. ओके, मग आता मुलांनो आता आपण इक्वेशन ऑफ कंटिन्युटी काढून घेऊ. ओके, व्हॉट इज द इक्वेशन ऑफ कंटिन्युटी इज टेलिंग A1 V1 at point P and Q. A1 according to equation A1 V1 is equal to A2 V2. इथला एरिया मल्टीप्लाइड बाय वेलोसिटी इज इक्वल टू दिस एरिया इनटू वेलोसिटी. एक लक्षात घ्या मुलांनो, एरिया लार्ज असेल वेलोसिटी कमी असेल, एरिया कमी वेलोसिटी विल बी लार्ज. सो देयरफॉर what will be the velocity at point 2? V2 is equal to A1 V1 upon A2. Okay, A1 upon A2 into V1. मग मुलांनो आता ह्या केस मध्ये त्या केस मध्ये काय केलं तर A2 खूप मोठा होता म्हणून मी त्याला इन्फिनिटी घेऊन V2 0 केला होता. इथे तशी कंडिशन येणार नाही, हा V2 आपल्याला पुढे त्या इक्वेशन मध्ये वापरावा लागेल. मग मी आता ह्या पॉइंटला आणि ह्या पॉइंटला बनवली इक्वेशन आता लिहतो मुलांनो आणि त्याच्यावरून त्याची व्हेलॉसिटी आता नोट करतो. ओके, मग आता आपण लिहून टाकू मुलांनो the Bernoulli's equation at point P as well as at point Q. तर आता पहिल्या पॉइंट P ला लिहू. ओके, by using the Bernoulli's principle. मग चला मुलांनो इथं पण आता इक्वेशन लिहावे लागतील आपल्याला. पहिलं चला घ्या इकडे, आता इथं सुद्धा मी कोणतं इक्वेशन वापरणार, प्रेशर एनर्जी पर युनिट व्हॉल्यूम म्हणजे P प्लस कायनेटिक एनर्जी पर युनिट व्हॉल्यूम दॅट इज 1/2 rho into V1 square. Okay, 1/2 rho into V1 square plus potential energy per unit volume that is rho GH is remains constant. Okay, पहिले इक्वेशन at point P. Okay, चला मुलांनो आता दुसरं इक्वेशन घेऊन टाकू आपण. दुसरं इक्वेशन P प्लस at point कोणत्या पॉइंटला रे, Q पॉइंटला लिहा. P प्लस प्रेशर एनर्जी पर युनिट व्हॉल्यूम. पण आता मुलांना एक गोष्ट तुम्हाला लक्षात आली असेल, इथलं प्रेशर आपण समजा पहिल्या पॉइंटचं काय लिहिले, प्रेशर ऍट दॅट पर्टिक्युलर पॉइंट विल बी P1. P1 प्रेशर आणि ह्या पॉइंटला आपल्याला प्रेशर काय टाकावं लागेल, P2, कारण इथलं प्रेशर वेगळं आहे मुलांनो, प्रेशर ड्यू टू हाईट. ओके, ते वेगळं आहे म्हणजे इथं P1 म्हणावं लागेल, इथं P2 प्लस 1/2 rho into V2 square plus rho into G into H, so that will be remains constant. Okay, मग मुलांनो आपण हे दोघं इक्वेशन लिहिल्यानंतर आता ह्या इक्वेशन मध्ये आपल्याला सॉल्व करावे लागतील हे दोघं इक्वेशन. याच्यामध्ये एक तुम्हाला टर्म दिसत असेल मुलांनो, कोणती, रो जी याची कॉन्स्टंट आहे बघा ती. जर हे दोघं इक्वेशन आपण इक्वेट केले तर माझं इक्वेशन कसं येतं बघा रे. आता इथे मी लिहितो वाटल्यास. ओके, हे इक्वेशन नव्हतं तर बाकीचं आपण पुसून टाकू. ओके, इथे लिहू, पण आधी पहिल्यांदा बाय इक्वेटिंग इक्वेशन 1 and 2 P1 plus 1/2 rho V1 square plus rho GH is equal to P2 plus half rho V2 square plus rho GH. rho GH get cancel. मी काम करतो आता मुलांनो, हा तुमचा प्रेशर. ओके, आता हे दोन पॉइंटचा प्रेशर आपण आता डिफरन्स काढून घेऊ. P1 minus P2 काय केलं याच्यातून हा वजा केला इज इक्वल टू तिकडे काय राहिला आता 1/2 रो V2 स्क्वेअर किंवा 1/2 आपल्याला तसंच ठेवावं लागेल 1/2 रो V2 स्क्वेअर मायनस 1/2 रो V1 स्क्वेअर. ओके, 1/2 रो इंटू V2 स्क्वेअर मायनस 1/2 रो इंटू V1 स्क्वेअर. ओके, हे आपल्याला आता इक्वेशन सॉल्व करावं लागेल. ओके, आता मी कसं सॉल्व करतो बघा मुलांनो. आता इथं पहिली गोष्ट V2 ची व्हॅल्यू आपल्याला टाकून द्यावी लागेल मुलांनो. कोणती व्हॅल्यू टाकावी लागेल, V2 तुम्ही काढून ठेवलाय बघा. ओके, व्हॉट इज द V2, A1 upon A2 into V1. आता इथे टाकतो मी. इथं इक्वेशन आपलं तयार होत आहे. P1 minus P2 is equal to 1/2 रो इंटू आता V2 ची किंमत ही टाकतो मुलांनो. ती किती आहे रे, A1 upon A2 into V2 त्याचा स्क्वेअर. ओके v2 कसा येईल रे हा v1 म्हणजे दॅट विल बी द v1 स्क्वेअर ओके मायनस 1/2 रो इंटू v1 स्क्वेअर चला म्हणून लिहिलं आता इकडे याला सॉल्व पण करून घेऊ आपण p1 मायनस p2 इज इक्वल टू हाफ रो a1 स्क्वेअर अपॉन a2 स्क्वेअर इंटू v1 स्क्वेअर मायनस 1 अपॉन रो इंटू v1 स्क्वेअर मग मुलांनो इथे काम करू 1/2 रो कॉमन काढा ओके किंवा 1/2 रो v1 स्क्वेअर कॉमन a1 अपॉन a2 स्क्वेअर किंवा a1 स्क्वेअर अपॉन a2 स्क्वेअर मायनस 1 करू p1 minus p2 पण मुलांनो p1 minus p2 is the difference of pressure at these two particular points that is equal to rho into g into h that is equal to 1/2 rho v1 square a1 square minus a2 square minus 1 rho will get cancelled आपल्याला ही velocity पाहिजे होती मुलांनो मग v1 square is equal to gh किंवा आपण आधी पहिल्यांदा एक काम करू इथं 2 times gh is equal to इथं आपण एक काम करूया v1 square into a1 square minus a2 square upon a2 square or v1 square is equal to 2 times gh into a2 square upon a1 square minus a2 square okay can you see I don't think you are going to see it properly मुलांनो आता याच्या पुढे इथे लिहितो मी वाटल्यास मग आता आपलं हे इक्वेशन कसं तयार होते बघा ही स्टेप परत इथे टाकतो v1 square is equal to 2 times gh into a2 square upon a1 square minus a2 square and so therefore v1 is equal to under root of 2 times gh a2 upon under root of